Review sheet L. I'm given a velocity time equation. I'm asked to find an equation for acceleration. If I had a velocity time graph, acceleration would be the gradient. So to work out the acceleration, I differentiate this v equation. So dv dt equals, bring the power down to the front, 6, and then take 1 off the power, plus 2, and that's my equation for acceleration. The next part of the question says, what is the acceleration after 2 seconds? So I'm going to substitute in t equals 2 into the equation I've just found for acceleration. So a equals 6 times by 2, which is 12, add 2 to get 14. That was part A. And in part B, it says use integration to find the distance travelled in the first 2 seconds. So I'm going back to this original equation, and this time I'm integrating it, 3t squared plus 2t with respect to t, to find the distance travelled. And in the first 2 seconds, so my limits are 0 and 2. So integrating, then integrate, I add 1 to the power and then divide by the new power. So I'll have 3t cubed over 3 plus 2t squared over 2. And between the limits of 2 and 0. This simplifies nicely then to the 3's cancel, and I've just got t cubed plus t squared between these limits. So substituting in, first of all, this 2 would get 2 cubed plus 2 squared. Take away, now substituting the 0. 0 is just going to give me 0 there. So 2 cubed is 8, 2 squared is 4, 8 plus 4 can give me 12 for the distance travelled in the first 2 seconds. Question 2, part A, we're asked to integrate the velocity, which we're given, between 0 and 1 hours. Integrate that with respect to t. So with my square brackets then I'm integrating, so I'll add 1 to the power and then divide by the new power. Between the limits of 1 and 0. So substituting in first of all this 1, get minus 0.5 cubed over 3. And then take away with the 0 substituted in for t. Every term contains a 0, so will just be 0. This first bracket then to work out this part here, minus 1/6. This part, minus 5/4. And this plus 3. Which gives me an answer of 19/12, or as a decimal, 1.58 for 3 significant figures. Part B asks me, what is it I've just found? Well, I've integrated between 0 and 1, so I've found the area under this slight curve. An area under the velocity time graph is the distance. So I found the distance that's travelled in the first hour. Part C is to find deceleration. So think of this as acceleration, and acceleration you would find by differentiating v. So dv dt equals, I multiply by the power, so minus 0.5 times by 2, and then take 1 off the power, minus 2.5, and it's disappeared. So my acceleration is minus t, that's from 0.5 times 2, minus 2.5. So when t equals 0.4 hours, I'm just going to substitute this value in. We'll have a is minus 0.4, take away 2.5, giving me an answer of minus 2.9. So the acceleration when t is 0.4 is minus 2.9. I'd expect that because I was actually told it was a deceleration. Because I'm asked for the deceleration, not the acceleration, my answer is 2.9.